In this video, we will be writing the equations of the lines and graphing linear equations. We're going to start off with slope, which describes the way a line is slanted, how steep it is. And there's a few ways to represent slope. One way is the change in y, which is the vertical change, over the change in x, which is a horizontal change. Sometimes we use a little triangle called delta, and we say delta y over delta x, which means the same thing. Or sometimes we say rise over run, which represents the change in y over the change in x. Sometimes we use a formula, and we say y2 minus y1 over x2 minus x1. And that's the formula we'll use when we have two ordered pairs to find the slope of a line. So looking at this graph, we've got a few different lines, and we're going to find the slope of each. Line A, if we find 2 points on the line, and we want to find points where the grid lines are crossing. Here's a good one. You can find a few good points to use. I can use any 2 points on the line as long as I'm finding points where the grid lines cross. And I make a triangle between any of those 2 points. And I do the rise, which is the vertical part, over the run, which is the horizontal part. And going from left to right, if I start at the top point, go down, and then to the right, I actually go down 2, and then, which is the negative direction vertically, but then I go to the right 3. So I could think of this as down 2, right 3. And so my rise over run will be -2 over 3. Now, if you don't think about the negative in that step, that's okay. Any line that slants down, we always read a graph from left to right. And from left to right, if your line is going down, 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 it has negative slope. So always make sure a line that is decreasing has negative slope. In part B, we have a vertical line. The slope of a vertical line is actually undefined. It has no slope. Part C is a horizontal line, and that has 0 slope. And part D, I'm going to find 2 points on the line. Any 2 points will do. As long as I find good points, I make a triangle, and I count the boxes or the steps I take vertically. So I'm going over to the right 5 and up 1, 2, 3, 4, 5 also. So my rise over run is 5 over 5 in this case, which reduces to 1. And we always want to reduce our slope to lowest terms. Now, notice any line that goes up from left to right is going to have positive slope, like line D. Any line that goes down from left to right or decreases will have negative slope, like line A. A vertical line will always have undefined slope. It has no slope. And a flat horizontal line, like line C, has 0 slope. Slope-intercept form is a general equation for any line, and that is y equals mx plus b, where m represents the slope and b represents the y-intercept of the line. In this next part, we're going to determine the slope between some points and from an equation. To determine the slope from 2 points, we're going to use our formula y2 minus y1 over x2 minus x1. Now, if we label our ordered pairs, the first ordered pair can be x1, y1. The second ordered pair can be x2, y2. And so I start by subtracting the y's on the top, and that's going to be 1 minus 6. And then whichever point I started with for the y's, I need to make sure I start with that same point for the x's. So now I'm going to do the x's on the bottom. I started with the second point, so I'm going to start with the second point again. And I'm going to do 2 minus 5. And then I simplify, and we get 1 minus 6 is negative 5. 2 minus 5 is negative 3. And those two negatives cancel out, and we get 5/3 for the slope. In the next example, same thing, same formula. I'm going to start with my second y and subtract my first y. 4 minus 4. On the bottom, we're going to subtract the x's. Negative 7 minus 1. And we get 0 over negative 8. And the question is it 0 slope or undefined? And it is 0. Whenever you have 0 on the top, that just equals 0. If you ever get 0 in the bottom, for example, if you had something like negative 8 over 0, that would be undefined. So you're not allowed to have 0 in the bottom of a fraction. But in this example, we did just get 0 because 0 was on the top. Now, when you are looking at an equation, if the equation is already in slope-intercept form, and you'll know because y is all by itself and x is on the other side, the number in front of x will always be the slope. So, in this case, that negative 2/3 in front of the x is the slope. Now, in part D, it's not in slope-intercept form. So we need to get the equation in slope-intercept form by solving for y first. To get y by itself, all we need to do is get rid of that negative 5. So we can actually divide both sides of the equation by negative 5. And I'm actually going to divide every term by negative 5. The negative 5's on the left will cancel. We get y by itself. And then I reduce. Negative 3 over negative 5, the negatives cancel, and we get 3/5. And then 10 divided by negative 5 makes negative 2, so we get minus 2x. And if you want your equation to look like y equals mx plus b, you could write your x term first and switch them around and make it negative 2x plus 3/5. So negative 2 would be the slope, and 3/5 is the y-intercept. In this next part, we're going to look at the different forms of the equation of a line. So we already talked about slope-intercept form. M is the slope, and B is the y-intercept. This is a really handy form for graphing because you can plot the y-intercept and use the slope to plot more points. The next one is point slope. We use that when we have a point on the line and the slope. So if you've got some x1, y1, some pair or ordered pair, a point on the line, and you know the slope, you use those two things to write the equation, and x and y will be the variables in the equation. And then the third form is called standard form. And in standard form, you get your x term and your y term on one side and a constant on the other side. But in standard form, a, b, and c have to always be integers. So A, B, and C cannot be fractions or decimals. And we'll talk about how to make that happen in a minute. And then the next one, a vertical line, x equals a. So anytime you have an equation where it's x equals some number, it's going to be a vertical line. For example, x equals 3 would be a vertical line passing through an x value of 3. And a horizontal line is always in the form y equals. So if you had y equals 3, it would be up 3, a horizontal line passing through a y value of 3. Okay, so let's look at some examples. First, we are going to graph the line x equals -4. So I go 4 spaces to the left, which is about right there. And if I plot all the points on this graph that have an x value of -4, any points on this vertical line have an x value of -4. So it's going to be that vertical line passing through all those points. So whenever it's in x equals some number, it's a vertical line. Okay, we're going to graph number 5 on the same line. Number 5 is an equation in standard form, but standard form is not the easiest form for graphing. I think slope-intercept form is an easier way to graph. So we're going to solve for y and change this equation to slope-intercept form. So the first thing we're going to do is subtract 5x from both sides, so that term moves over to the other side. And we get -2y equals -5x plus 10. And now to get rid of the -2 in front of the y, we're going to divide both sides by -2, and we have to divide all terms by -2. So we end up with the -2's cancel, y equals, the negatives cancel, and we get +5 over 2x, and 10 divided by -2 is -5, so -5. And now when I graph this line, I'm going to start by plotting the y-intercept. So the y-intercept, or b, is -5. And the slope, m, is 5 over 2. So I go on the y-axis and I find -5, and that's going to be my y-intercept. Now my slope of 5 over 2, that's my rise over run. So if I start at that point on the y-axis where I started out, and I rise 5 and run 2, and both are positive, so I'm going to go up 5 and to the right 2, then I get some more points on the line. So I go up 5 and right 2 again, up 5 and right 2 again. And I can also go down 5 and left 2, because that's also comes out to a slope of +5 over 2. So down 5 and left 2 works as well, and I've got a bunch of points on that line. And you always want to make sure your line is slanting the right way. I did have positive slope, and my line is going up from left to right. It's increasing, so I should be in good shape. Another common mistake is mixing up rise and run. So make sure you're careful that the top of the fraction is how far you go up, and the bottom is how far you go to the side. Okay, in the next example, number 6, this equation is in point slope form. So you have a few choices. You could simplify it and put it in slope-intercept form, or you could just graph it from point slope form. In point slope form, the formula y minus y1 equals m times x minus x1, there's minuses in front of the y1 and the x1. So when we are trying to figure out what point we're talking about, negative, the -3, 3 is going to be y1. And when it says x plus 1, negative 1 is actually going to be x1. Since there's minuses in the formula, the numbers appear to be the opposite. So the point on this line, a better way to write it, would be negative 1, positive 3. And the slope is negative 4/3. So what I can do is start at the point negative 1, 3, plot that point, and then use my slope of negative 4/3 to plot some more points. And I can think of this as negative 4 over positive 3 or positive 4 over negative 3. So I could go down 4, right 3, down 4, right 3. I could also go up 4 and left 3. And once I have a few points, I connect them, and there's my line. Now in part 7, we have just normal slope-intercept. The slope is 2, the y-intercept is 7, negative 7. So we plot a point at negative 7 and a slope of 2. I go up 2 over 1, up 2 over 1, because the slope of 2 is like 2 over 1. And I plot a few points and then connect them to make the line. And the last one in this part, y equals negative 5, is going to be a horizontal line that goes through all points in the graph that have a y value of 5, which is going to be a horizontal line passing through y equals 5. In this last part, we are going to look at a graph and write the equation in all three forms. So starting with slope-intercept, that's y equals mx plus b. First, I want to determine the slope. So if I look at 2 points on the graph, I make a triangle, and in this one, I'm going down 1 and to the right 4. So the slope is going to be negative 1/4. The y-intercept is the point where the graph touches the y-axis. And the y value at that point, which I just made blue, is negative 1. But we should write it as an ordered pair. So the y value, or the slope-intercept, is, just kidding. The y-intercept is negative 1, but that point will be 0, negative 1. So writing the equation in slope-intercept form, we get y equals, we put the slope, negative 1/4 x plus the y-intercept, which is negative 1, so we go minus 1. Now, writing that equation in point-slope form, we use the same slope, negative 1/4, and we use any point on the line. I'm going to use the point 4, negative 2. And the equation is y minus y1 equals m times x minus x1. So the x1, y1 is the point you use. The other x and y are variables, so they just remain variables. So I do y minus the y coordinate, which is negative 2. And then I put the slope in for m. And I do x minus the x coordinate, which is 4. And I'm going to simplify that. Instead of writing y minus negative 2, which looks confusing, I'm going to get y plus 2 equals negative 1/4 and x minus 4. And that's point slope. Now our last step is converting to standard form. I think it's a little bit easier from slope-intercept form.
So I'm going to start with my slope-intercept form. And to get to standard form, which is ax plus by equals c, we want to get the x and y terms on the same side. So first I'm going to move the 1/4 x over to the left side by adding it to both sides. And if I rewrite that, I get 1/4 x plus y equals -1. Now, we're not allowed to have any fractions or decimals in standard form. We have to have integer coefficients. So we want to make any number in the denominator go away. And since I have a 4 in the denominator of a fraction, I'm going to multiply both sides of the equation by 4 to cancel out that fraction. So if I multiply by 4, my 4 and the 1/4 cancel, and we just get x. 4 times y is 4y, and -1 times 4 is -4. And I check my coefficients, make sure they're all integers. They can be positive or negative, but I can't have fractions or decimals, and x and y are on the same side. So that would be standard form. And this last example I am not going to show because this video is getting really long. So you guys can try that one on your own, and I'll post a complete answer key.